All right, well, welcome to the second part. Sorry about that. My computer freaked out a little bit. That's all right. I freak out a little bit every once in a while too, so I don't blame it. Okay, so now, as you can see, now we want to do g of f of x. So what does that mean? Again, I look left to right. It says g of f of x. So what I'm going to look at here is what is f of x, right? So in that case, it is this guy right here, 2x minus 5. So what do I want to take g of? I want to take g of 2x minus 5 now, right? I've just literally replaced f of x with what that function is. It's 2x minus 5. And now, again, what does it mean to take g? Like if I asked you to take g of 4, right? What would you do? You'd come up to g. You would do 4 squared minus 3 times 4 plus 8. We've seen this notation before, guys. We saw this notation when we dealt with dealing with function notation. So everywhere I see an x, I'm going to put that 2x minus 5. So I would have 2x minus 5 quantity squared minus 3 times 2x minus 5, right, plus 8. And you would simplify this. So I'm not going to spend the time in this lecture to simplify it, but you would FOIL this out. You would take the negative 3 through, and then when we combine like terms. I hope that makes sense. Let's try, actually, I'm going to just do this because I want to keep using these functions. And let's do a couple more examples with these functions here. Leave that there in case you need it. All right. So what about if I asked you to take f composed with g of 7? Now we had found what f of g of x was, so I could just take that function I had found before for f of g of x and just plug in 7. Or if we look at this, let's look at what this means to take f of g of 7. So I'm going to work my way in. So 7 is my input. What function is going first? G. So I'm going to do a little bit of work over here. What would g of 7 be? Well, that'd be 49, right? Minus what? 21 plus 8. Oh, man. I'm not going to lie. I'm getting my calculator. I shouldn't. But I just want to make sure I don't make a mistake. So what do we have here? We get 36. So what is g of 7? G of 7 is 36. So what does this become? F of 36. So do you see this composition happening, right? So 7 has been mapped from g to 36. And now I'm taking my function f and I'm taking that result and I'm going to plug 36 into f, right? I think I can do that. I don't know though. You know, the higher I got in my math career, the worse my arithmetic skills got. So look at this. What this is saying, under the composition f composed with g, 7 is mapped to 67. Okay. What about, and we could do the same thing with g composed with f as well, if we wanted to do that. And we do want to do it. It's just, we have other stuff to do, so I'm going to go to the next one. What about g composed with g of 1? So again, you're just going to follow the order here. Rewrite this. I really recommend rewriting this each time. I'm going to take g of 1. So let's just start from the inside. What is g of 1? That would be 1 squared minus 3 plus 8, right? I can do that. That's negative 2 plus 8, which is 6. Look at that. I'm good. So this is g of 6, right? And now we just want to figure out what is g of 6. I can do that right here. So that would be 6 squared minus 3 times 6 is what? 18 plus 8. So I think that's 26 altogether. Check my arithmetic on that, and if it's wrong, don't tell me. It probably is wrong, but oh well. And then one other one really quick that can be a little bit tricky that I just want to show you. I was going to do it over here. Is what if I wanted to take f composed with f? What would happen there? I don't know. Probably something cool. So this is part D. So let's take f composed with f of x and see what happens. So this is f of x, right? All right, so what is f of x? F of x is just this function right here, 2x minus 5. So this one's a little crazy. It kind of feels like you're chasing your own tail here. But what does this mean to take f of 2x minus 5? It means anywhere I see an x, what am I going to replace that x with? Whatever's in the parentheses. So I would have 2 times, not x anymore, but 2 times 2x minus 5. It's a little freaky, huh? It's like the movie Inception or something. Or Alice in Wonderland. So I would get 4x minus what? 10 minus 5. So I get 4x minus 15. I hope that makes sense. Composition can be a little bit complicated just because it's like trying to figure out kind of what you're composing. You guys have already been doing composition. When you did that difference quotient and you were putting x plus h in, it was technically a composition because you were replacing that x with a function. So don't let that freak you out. Just be consistent with how you write it left to right, and I think you'll see it's not too bad. Now, where can we get a little bit more, let's say, interesting? When I want to start looking at maybe domains of functions, that can be a little bit tricky. So let's consider domains of compositions of functions. So consider f of x equals square root of x, and let's have g of x be x plus 2, okay? All right, so part A, let's evaluate f composed with g of x and its domain. All right, so here's what we have to consider when we're looking at domain, right? So f composed, again, I'm going to rewrite this so I know what I'm doing every time. This is f of g of x, right? What is g of x? It's x plus 2, so this is f of x plus 2, and then I'm going to replace this x with x plus 2. So this becomes x plus 2 right here. Okay, so we have to think about this. Let's talk about the domain of G. What is the domain of G? G is saying everyone is invited to the party, right? We have no issues with fractions. We don't have a 0 in the denominator because there's no denominator. Technically there's a 1, but we have no variable in the denominator. And also the square root, there's no square root. So remember, why am I only caring about G right now? Because G is going first. G is the first one to write invitations to the party. So G has decided that everyone is invited to the party, okay? So that's great, except that now F is going to be evaluating the results of what G, after G invites everyone, what happens. And so now look at this new function. Now I know this can be a little confusing because you might want to consider the domain of f of x, but remember we're not taking f of x anymore, we're taking f of g of x. So what you want to first consider is, does G leave out any x's from the party? Is there anything in the domain that G has to leave out? And then now what I want to look at is I want to look at my resulting function, and I want to see, once I have simplified that resulting function, because of the nature of that simplified function, does this function have to spit out anything? And it does, right? We have a square root. So we have to make sure that everything underneath that square root is greater than or equal to 0. So x must be greater than or equal to -2. So what is the domain of my new composition of functions? -2 to infinity, okay? So again, remember, just because G said everyone was invited, my final resulting function, I have to consider, does that resulting function imply any other restrictions on x? Let's look at the other way. G composed with f of x and its domain. So domain is always a little bit tricky, right? Domain can be kind of fickle. I mean, it's not. Everything in mathematics is pure and true and what it should be, but all right, what is f of x? F of x is root x, so I just replace that f of x with root x, and then in G, what am I going to replace that x with? The square root of x plus 2. All right, up here, what was the domain of f? Well, x had to be greater than or equal to 0, right? So my domain for square root of x was 0, including 0, up to infinity. So we know right away, my domain for my composition must at least, right, have the restriction of 0 to infinity, okay? Because f remember, F's going first. So F is not going to invite any X values to the party other than 0 to infinity. So positive X values, including 0. So now what we want to look at is, okay, so I know here that X must be greater than or equal to 0, right, from F. Now I'm going to look at my final answer and I'm going to see if when I applied G, did that bring in any other restrictions to my domain? Did the fact that G applied itself to f of X bring in any other restrictions? And it doesn't in this case, right? Because I still have this square root of X. Adding 2 to that isn't going to throw out any other X values. So what is my domain going to be? It's just going to be that domain of F. Look at that final function, right? You can kind of see that because this is my f of X right here, this guy right here, even if I were just to find the domain of this function, not knowing it was a composition, its domain would still be 0 to infinity. I hope that makes sense. Let's look at another one. Oh, I'm stretching. All right, so one more example like this, because these domains, they can be they can be a little bit tricky. So let's look at f of X equals 1 over X plus 1, and G of X maybe equals 3 over X. So let's find, again, F composed with G. These are a good time, of X and its domain. I love it when fractions come into play. I know you do too. The nice thing about doing a lecture to myself in my office is I can just pretend that you guys are responding with, you know, Sarah, I really do love fractions, and I like working with them. They make me happy. That's what I'm pretending you're saying right now. All right, so I'm going to take f of 3 over x. Okay, so this is going to get a little crazy, but we are not scared. No big deal. All right, so f of 3 of x. So where is my x in my function f? My x is right here in the denominator. So instead of having an x there, I'm going to have a 3 over x. And before we get any further here, I'm going to, the domain of this guy's everything but 0, right? So I'm not even going to do like a formal thing here. This is everyone but 0. Why don't I care about what f of x's domain is? Because f of x doesn't get to choose x's first. So right now, all I care about is what g is going to leave out. And right now, g is going to leave out 0. Okay, look at this gross fraction right here. I don't want to call it gross. It's not gross. It's just not in a form that is super useful to us. So this is called a complex rational expression. One easy way, well, easy is probably pushing it a bit, but one way of trying to simplify a complex fraction is to look at all the denominators that you have inside the fraction. So what's the only denominator I have? It's x. And you want to take the least common denominator of all those denominators, which in this case would be x. And you're going to multiply the entire denominator and the entire numerator by that x. The reason that works is that cancels out that x in the denominator. So on the top, I get an x. On the bottom, I'm going to take this x through. Look at that. The x's cancel, and I just get 3. And then down here, 1 times x is x. How else could you do it? You could get a common denominator with that fraction, 3 over x, and 1 on the bottom, and then flip it once you get that single fraction. But I think this is easy. That's an easy way to get rid of it. I want this x to go away, so I multiply top and bottom by it. And look at that, that's so nice. So look at, this is my final answer, right? So again, we know for sure that x cannot be 0. I don't care, that sounds kind of mean, but it doesn't matter that x being 0 in my final answer, what doesn't look like it causes problems, it would cause me a problem right here before I simplified. 0 isn't even on the table, you guys. 0 wasn't even considered at the very beginning, didn't even get an invite, okay? Now that I have my final simplified composition, are there any other x values that have to be thrown out? It looks like there are. X cannot also cannot be -3, okay? So -3 is like invitation gets taken away. 0 never got an invitation at all. And then -3, once we kind of simplified things and found out who -3 really was, -3 had to be left out as well, okay? So what's the domain of my function? Set notation, it's all x such that x cannot be -3 or 0. If I want to do that in interval notation, let's go from -infinity up to -3. Ooh, but don't grab it, so open parenthesis, Then I can go to the right side of -3 up to 0, but don't grab either one of those, and then 0 to infinity. Okay, hope that makes sense. Again, I look at my simplified composition function and I see if there's anything else that that simplified function has to leave out. Of course, let's do the other way. And it's still me. I love doing these. These are so fun. All right, so G composed with f of x. Again, what does that mean? That means it's G of f of x. Okay, what is f of x? It's 1 over x plus 1. Okay, what does G do? It takes 3 over x. So instead of 3 over x, I'm going to have 3 over 1 over x plus 1. Before we get too crazy here, let's remind ourselves what x cannot be because f is going first, right? F will never grab -1. Doesn't even get an invite to the party, people. Cannot be -1. Okay, and then here, yeah, I have a complex fractional expression, but it's not as complicated maybe as this one because we don't have a fraction plus something that's not a fraction. We just have a whole fraction on the bottom. So remember what we do with fractions. When we divide, we flip them and multiply if it's just a single fraction. So look at this. Our answer here is 3x plus 3, or 3 times x plus 1. I don't know. I kind of like that better. Why do I like that better today? It doesn't really matter. 3 times x plus 1. Okay, so what do I know? I know for sure that -1 is not invited to the party. Now I look at the resulting composition and I see, is there anything else that x cannot be in this? Clearly not. I mean, we're fine. Look at it's just 3 times x plus 1. It's just a nice little line. Normally, these guys, everything is invited to the party, except remember -1. -1 wasn't even considered to begin with. So this does not impose any other restrictions on f. So what is my domain? Apparently we're doing this in purple. Lx such that x cannot be -1, right? -1 wasn't even considered, people. F went first and f decided -1 can't come. Even though -1 has tried to redeem itself by bringing the x plus 1 up top, doesn't matter. Interval notation, minus infinity to -1, union -1 to infinity. Okay? I hope that makes sense. I hope that makes sense. All right, you guys, that is about it for this section. There's some stuff in this section about decomposing composition, but you know, honestly, you're not going to worry about that really until you get to calculus, and so we're going to kind of skip that in this section. Just I'll have you guys focus on domain and the actual algebra of the composition. All right, let me know if you have any questions.